spelled with 3 S's and an E.
Okay, welcome everyone.
I didn't even know that
So,
existed.
last one for the term. So, we've got a little bit to do. This is pretty exciting. I like doing this. So, what we're doing is we're solving exponential equations. So, an exponential equation, all right, where the variable is an x, okay, the variable is an exponent, so hence solving exponential equations, by equating the base. That means we need to write them with the same base. And so perhaps the very first thing that I should show you guys is just the first sort of powers. So if we've got 2, we can have 2 squared is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16. For 3, we have 3, 9, 27 and 81. Okay, 3 squared, 3 to the power of 3, 3 to the power of 4. 5, 25, 125, 625, and that's probably enough. Okay, so we'll just keep those numbers up there. They're sort of ones you probably expected to know with this exercise. So what we have to do here is we have to express both sides with the same base. Alright, so this one, we've got 9 is just 3 to the power of 2. Now because they have the same base, and the left side equals the right side, it means the powers are equal as well. And so the solution is x equals 2. Alright, we express them both as a base of 3. 3 to the x equals 3 to the 2, therefore x is 2. Okay. Here, we need to express them as the same base. We've seen 9 is 3 squared. So what we have is 3 squared to the x. 3 by itself is 3 to the 1. And so we've got 3 to the 2x is 3 to the 1. Okay, by the index laws. And so then we have 2x is 1, x is a half. Okay, 4 to the x is 8. Alright, so here we may have to make both powers because 8 is not a simple power of 4, but we can express 4 as 2 to the power of 2, and 8 is 2 to the power of 3. And so we have 2x is 3, and x is 3 on 2, 1.5. Okay, 3 take 2x, 3 to the power of 2 take x is 27 to the x, and we need to express this as the power of 3. We're going to equate the powers. 2 take x is equal to 3x. We'll shove this x over the other side. So we'll have 2 is 4x, and we'll get x is 2 on 4, which is a half. Okay. So just here, plus x to both sides, dividing both sides by 4, and I wrote the x on the left side rather than the right side. Okay, when we have a product in there, we've got this number 3, our very first step is to get rid of that because we just want the base on both sides. We don't want any multiples. So we're going to get rid of this 3, we divide both sides by 3, and we're going to get 4 to the x take 1 is equal to 16. Okay? Now we can express 16 as a power of 4. And then we equate the bases. X take 1 is 2, x is 3. Okay, half to the x. This one's a little bit tricky. What we're going to recognise here, I'll talk about this side first, is we've got 1 on 2 to the power of 1. Now one of our index laws is 1 on a to the n is equal to a to the minus n. So that means we're going to express this as 2 to the power of minus 1. Okay. Over this side, we've got 1 on top of 2 to the power of 3. And so here, we're going to have 2 to the minus x equals, and over here, because it's at the bottom, we can write it at the top, but we change the power from being positive to negative. 2 to the negative 3. We have negative x is negative 3, because we've got the same base, and so therefore x is 3. So pretty cool skill. Any questions? So what we're working through today, we've got a big booklet here. So this is what we'll be working on at the start of next term as well. So from this, just questions 1, 2 and 3. Okay? We'll see how we go today. I anticipate that's probably all we'll do. You may find it really easy and you can move on if you like. I can show you the next part, it'll be pretty straightforward too. Any questions? No, I'll hand this out and let's